Okay, so the first question of the test asks us to graph the function f of x is equal to x squared plus x minus 6 divided by x plus 2, and asks us to state the domain and range, type of asymptotes, equations of any asymptotes, x and y intercepts, positive and negative intervals, and behavior around any vertical or horizontal asymptotes. Okay, so the first thing I noticed about this equation was the fact that the first degree up here is higher by 1 by the second degree up there. And if that's the case, that means there's going to be an oblique asymptote. So knowing that there's going to be an oblique asymptote, which I've stated here, we need to do polynomial division to find out the remainder. So once that is done, the remainder is negative 8. So using remainder theorem, if we write that out, that is x plus 1 plus negative 8 divided by x plus 2. And obviously, because the x is going to be infinity, and anything divided by infinity is going to be 0, this whole thing is going to be 0, which leaves the line x minus 1. So the line slants towards x minus 1. It tends towards x minus 1. Okay, so knowing that, we go back to the original equation, which was x squared plus x minus 6 divided by x plus 2. And we factorize the function at the top to give us x plus 3, x minus 2, and x plus 2. So as we can see here, we're not crossing anything out, so there are going to be no holes because there's no discontinuity because we're not crossing any part out. Okay, and when the graph is sketched, it is going to look something like this, I believe, and the explanation of this will come later. But for now, we're going to state the domain and the range. As we know that the domain is equal to the so as we know that the domain is equal to the vertical asymptote, and for here we know that our vertical asymptote is negative 2. So our domain is going to be negative 2 as well. And the range is also the horizontal asymptote. And since we don't have a horizontal asymptote, so HA is going to be 0. No, we don't have a horizontal asymptote, sorry. So there is no horizontal asymptote, so therefore there is no range. No range. It asks us to describe the types of asymptotes. So as we've seen here, as mentioned earlier, we have the oblique asymptote because of the degree 2 and 1. The degree at the top is higher by exactly 1 degree. And we also have a vertical asymptote here, which lies at x equals to negative 2. So x cannot be negative 2. Equations for any asymptotes, as mentioned, x cannot be negative 2. And we also have the oblique asymptote, which is y equals to x negative 1. X and y intercepts. Okay, so going back to the graph, we can find the x-intercept by using the numerator at the top here, and so the numerator has to equal to 0. So for here, x plus 3, what would make x plus 3 0? That would be negative 3. So we have our first x-intercept is negative 3. And the second y-intercept, what would make x negative 2 equal to 0? which would obviously be 2. So our second x-intercept is 2. Also, there's the y-intercept, and the y-intercept would simply be, going back to the main equation, -6 divided by 2. And -6 divided by 2 is -3. So we have a y-intercept of -3, which is seen in this graph as you have the x-intercept of -3 and 2, and we also have the y-intercept right here, -3. Okay, so positive and negative intervals. So this means when our point in the graph was x greater than 0 or x less than 0. So looking at the graph, we see that x is greater than 0 in 2 places. One is here, so that would be when x is greater than 2. So x greater than 2, and also where x is greater than -3. So x is greater than -3. Okay. And we also have the negative interval, so that's when the graph is below 0, and the graph is below 0 when x would be less than -3, x less than -3, and x is less than 2. Okay, and last but not least, we have the end behaviors around any vertical or horizontal asymptotes. So as mentioned earlier, because of the oblique asymptote, the graph was gonna tend towards x -1. So we see towards the end, graph is gonna move towards x -1, but it will never make contact with it. And the same applies for the other side too. Moves towards it. And as there's no y-intercept, as there's no horizontal asymptote, that doesn't count as well. And for the vertical, as for the vertical asymptote, when x gets closer to 0, y y goes to infinity, sorry, no, as y gets closer to 0, x is going to tend towards x equals to 1. And the same applies to here as well. X is going to tend towards x negative 1. Yeah.